These jeans were built for durability, not for comfort, not for fashion, not for the shelf at a retail store. What looks simple on the outside, 2 legs, 5 pockets, a zipper, is the result of a highly controlled industrial process that spans multiple continents, involves dozens of specialized facilities, and has been refined over more than a century of manufacturing iteration. Almost no one who wears a pair of jeans has any idea what actually went into making them. Most people see a product. What they are actually looking at is a system. And once you understand the system, you will never look at a pair of jeans the same way again. The system. This is not just clothing. It is an engineered supply chain, built across continents, controlled at every stage, and optimized over decades for consistency, scale, and output. The finished product, sitting on a store shelf, represents the endpoint of a process that began months earlier, thousands of miles away, with something that looks nothing like a pair of jeans. To understand it, you have to start at the source. Cotton. Every pair of jeans begins as raw material. Cotton, a natural fiber that looks deceptively simple at harvest, white, soft, and abundant. But cotton varies significantly in quality, and those variations matter enormously in an industrial context. Fiber length determines strength. Longer fibers produce stronger, more consistent thread. Fiber consistency determines how uniformly the material behaves during processing. Purity determines how the fabric responds to dyeing, washing, and finishing treatments later in the production chain. A small variation at this stage compounds into a significant quality difference by the time the garment is finished. After harvesting, the cotton goes through an initial cleaning process. Seeds are separated from the fiber. Plant debris and contaminants are removed. The material is standardized to a consistent specification. Only then is it compressed into large bales and prepared for industrial transformation. What arrives at the textile mill is not raw field cotton. It is a controlled, standardized input material ready for the next stage of processing. Yarn. Inside textile mills, the first major transformation begins. The cotton bales are opened, and the raw fibers go through a series of mechanical processes designed to align, straighten, and refine them into a uniform structure. Remaining impurities are removed. Short or irregular fibers are separated out. What remains is a clean, consistent mass of aligned fiber ready for spinning. Spinning is where fiber becomes thread. The fibers are drawn out under tension and twisted together to create yarn. This step is more consequential than it appears. The tighter the twist applied during spinning, the stronger the resulting thread. And that strength, built into the yarn at this early stage, directly determines how the finished fabric will perform under the stress of daily wear, repeated washing, and years of use. The yarn coming off a spinning mill is not yet denim. It is the structural foundation that denim will be built from. Everything that follows depends on the consistency and quality of what was produced at this stage. Denim. Once the yarn is ready, it is woven into denim fabric. Denim is not a standard plain weave. It is a structured fabric produced using a specific method called twill weave. In a twill weave, the threads are interlocked in a repeating diagonal pattern rather than a simple over-under grid. This diagonal structure is what gives denim its characteristic surface appearance, its flexibility under stress, and its combination of durability and movement. But the defining technical detail of denim, the one that separates it from every other woven fabric, is in the dyeing. Only the outer threads are dyed with indigo. The core of each thread and the interfacing threads remain undyed. White on the inside, blue on the outside. This is not an aesthetic accident, it is a deliberate engineering decision. Because the indigo dye sits only on the surface of the outer fibers, it gradually wears away with use. The fabric fades. It develops creases, wear patterns, and variations that are unique to how each specific garment has been worn by each specific person. Denim is designed to evolve. It is one of the only industrial fabrics in mass production that is intentionally built to change its appearance over time, to develop individual character through use rather than despite it. Assembly. Now the fabric becomes a product. The denim arrives at a cutting and assembly facility where the first step is pattern definition. Each component of the finished garment, front panels, back panels, pockets, waistbands, belt loops, is defined by precise templates. The fabric is layered in stacks and cut with industrial precision to produce consistent components at scale. Then stitching begins. Seams are constructed in a specific sequence. Components are joined together. The three-dimensional structure of the garment is formed from flat pieces of fabric through a carefully choreographed assembly process. Industrial sewing machines running specialized stitch types handle different parts of the construction. Some seams require strength, some require flexibility, some require both. At key stress points, The corners of pockets, the base of belt loops, the crotch seam, metal rivets and reinforcement stitching are added. These are not decorative details. They are structural solutions to the specific points where denim garments historically failed under stress. The rivet, patented by Levi Strauss and Jacob Davis in 1873, was one of the earliest examples of failure analysis driving product design. It remains standard practice in denim construction for the same reason it was introduced. It works. Transformation. At this point in the process, the assembled jeans are still raw, stiff, rigid, and unwearable in any comfortable sense. The fabric has not yet been softened, and the indigo surface has not yet been treated. What exists is structurally complete but experientially unfinished. So the garments undergo transformation. Washing softens the fibers and begins the process of relaxing the fabric's rigidity. Different washing treatments produce different results. Stone washing, tumbling the garments with pumice stones, creates the worn, distressed surface patterns associated with vintage denim. Enzyme washing uses biological processes to break down surface fibers more gently, producing a softer hand feel without the aggressive abrasion of stone washing. Additional distressing treatments, sanding, scraping, localized bleaching, add visual character at specific points on the garment. Every one of these processes is controlled and intentional. The finished appearance of a pair of jeans that looks casually worn is the result of a precise industrial process designed to produce that specific look consistently across thousands of identical units. The character is manufactured. The variation is engineered. Final quality control. Before the product leaves the facility, it is completed and inspected. Buttons and zippers are attached. Labels, rivets, and branding hardware are added. Then every detail is checked against specification. Every seam, every stitch alignment, every component placement. At scale, consistency is what separates a reliable product from a defective one. Quality control at this stage is not bureaucratic overhead. It is what makes the system trustworthy. The modern system. Today, the production system that builds denim garments continues to evolve. Water consumption, historically enormous in denim finishing, is being reduced through process innovation. Synthetic indigo is being reconsidered alongside plant-based alternatives. Recycled cotton fiber is entering the raw material supply chain. Laser finishing is replacing some of the water and chemical-intensive distressing processes. Modern denim production is no longer measured only by output. It is increasingly measured by impact, resource consumption, chemical discharge, labor conditions, and material traceability. The system that built the world's most common garment is under pressure to rebuild itself, and the direction of that rebuild will determine what the next century of denim production looks like. From raw cotton in a field to a finished garment on a shelf, this is not just manufacturing. It is engineered consistency applied to a product so common that most people have stopped seeing it entirely. Every stage controlled, every variable managed, every decision traceable back to a structural or economic reason that has been tested over decades of industrial refinement. Most people just see jeans. Now you understand what actually builds them.